Good morning, everybody, and welcome to this morning's Technology Insight webinar. My name is Mark Whelan. I'm the Programme Manager for the Technology Gateways Programme in Enterprise Ireland, and I'll be your host today. And I'm delighted to welcome our speaker today, Dr Oisín Boydell, who's the Principal Data Scientist in the CeADAR Technology Centre. I'll let Oisín introduce himself a bit further when we get to that. I suppose just some housekeeping before we start. You should see in your options down the right-hand side that there is a chat and a questions function. Please feel free to use those, particularly the questions. So the idea of the format today is that Oisín will present for about 25-30 minutes, and then we'll have a 10 to 15 minute question and answer sessions that I will run. The idea of the webinar really is to try and educate people in the new technologies, provide insights into those, and I'm delighted that we're talking about blockchain and AI this morning. So I'm just going to hand over to Oisín now, and I'll see you all again hopefully for the questions in a while. Thank you.
Thanks very much, Mark. Good morning, everyone. I'm going to talk today about blockchain and AI, and how distributed ledger technology can support blockchain through a shared and trusted data model. I'm going to cover two key technology areas which are hugely sort of popular. They're very sort of hyped up areas over the last number of years, and these are blockchain and artificial intelligence. And I'm going to talk about how these can be connected together, I suppose, where blockchain can support artificial intelligence. So what I'm going to talk about first is going to give an introduction and overview of blockchain. So blockchain is often described in either very technical terms, in terms of how it works, or also in terms of its application in some sort of specific use cases and specific industries. But what I'm going to try and do is describe sort of the sort of general problem it solves. And then that hopefully can allow people to start thinking about how that can solve problems in their own areas, in other use cases that they might have. So I'm going to try and give it from that kind of perspective. Then I'm going to talk about AI and how really there's a number of challenges with the adoption and deployment of AI, and a lot of these are around the data that AI relies on and that AI is built on, AI techniques. And then how these two come together. So how blockchain can work to support and address some of these challenges that are encountered when AI is deployed around the data and so on. So firstly, I'm going to just give a brief overview of CeADAR. So what CeADAR is. So CeADAR is Ireland's Centre for Applied AI. I'm Principal Data Scientist, and I also lead the Applied Research Group in CeADAR. And what CeADAR does, we're a market-focused technology research centre. We're part of the Technology Centres programme supported by Enterprise Ireland and IDA. We're based at University College Dublin. We also have links with TU Dublin. And we're very much a market-focused centre. So we work with industry partners, we work with companies in deploying and helping those companies use AI technologies, and particularly a lot of the more cutting edge AI technology, such as blockchain and some of the latest sort of innovations in AI. And we work across quite a range of different areas. So one of the things about AI, data analytics, machine learning, they're quite cross-cutting technology. So they can be applied across a wide range of different industries, different areas, different types of companies, because these days all companies, all industries generate lots of data, and there's lots of opportunities in applying AI all across these. So, as you can see, we work across quite a lot of different industries, and also with quite a broad range of different technology areas, which are all kind of come under this broader AI and data analytics umbrella. And you'll see blockchain and smart contracts related to blockchain is one of the key areas that we work on, and we've a number of projects. I'll go into details of one of those later. And finally, about CeADAR, the centre. So we work with companies directly in contract research, in working directly individually with companies. We work on a lot of collaborative research projects, European funded projects funded under Enterprise Ireland's Innovation Partnership Programme, Disruptive Technology Innovation Fund, and other national funded research and development projects. And we also do this demonstrator program where we produce these projects with various company partners across a wide range of technology areas to show those companies and give them examples, demonstrations of these tools that they can then take and use. So there's a wide range of these, as you can see, and there's more information on our website, CeADAR.ie. So now moving into first part on blockchain, and blockchain is also known as distributed ledger technology. So you might have heard those both those terms. So distributed technology, ledger technology really it's a sort of more umbrella term for blockchain, but blockchains may be a more specific way of solving that problem, a specific technology solution to do this. But blockchain is sort of a more catchier term, I think, than DLT. So it's kind of stuck. So in explaining what blockchain actually is for, what it actually does, what problem is it solving, you can think of this as a number of aspects. But one of these is the double spending problem. So what the double spending problem is if we imagine you have a physical asset. So in this case, this example, Tom gives Jerry a physical asset. It's a piece of cheese. Now, there's no double spending problem in it. It's a physical asset. You can't duplicate that physical asset. It exists in itself. So Tom cannot give that block of cheese, that piece of cheese to Jerry, and also give that to someone else. There's only one of those. It can only be done once. So there's no double spending problem in this case. However, if we imagine digital assets, so a digital bit of information, a digital token, that can be easily copied, can be easily duplicated. So unlike the physical asset, Tom could just copy that digital asset, give a copy to someone else, and then they're double spending that asset. Now, the way that's managed currently and traditionally is through middlemen, through a trusted authority, a trusted third party. And in the example of currencies and tokens of value, this would be like central banks, clearing houses, and so on. So when Tom gives a certain asset to Jerry, a digital asset, the bank keeps a record of who owns what and where that's been transferred. Everyone trusts the central authority, the central party, this central bank, and they are the holder of that bit of information. And this solves that double spending problem because everyone can rely on the data, the information that central authority has is the source of truth, the single source of truth. However, what decentralized ledger technology does, or a blockchain solution, is it allows to remove that central trusted party, and the blockchain network itself, the technology maintains that trust, and everyone can see, although they're sharing that information around between each other, and everyone can see who has what, and they can trust that network, what is stored on the blockchain is the trusted source of authority. So it solves that double spending problem. People can see that Tom is not duplicating a digital asset and providing it to someone else in this example. And as we can see in this example, it's talking about Bitcoin, because Bitcoin is very much linked to blockchain technology. In fact, blockchain was developed, the idea first came about when Bitcoin was first developed. So is very much blockchain is often talked about in the context of digital cryptocurrencies. Another way of thinking about this problem is around just digital information itself, and how it can be copied and shared at near zero cost. And this is, this has been incredibly useful, incredible innovations out of this. So if you think of traditional libraries, information is on printed books. It's very hard, or it's expensive to duplicate that information. You need to create a new physical copy of that book, distribute that, and so on. And compare this to how information is shared mostly these days over the internet. Anyone can publish a blog. It's accessible to many, many people. You can copy that information, you can share it around. There's near zero cost in doing that, and it's it's transformed nearly everything we do. Same thing with audio and music, for example. So traditional approaches, it had to be produced on physical media. Copying that was, it's complex. There's a cost involved in that. And compare that with how digital audio is distributed today. It can be easily distributed, and there's so much less cost in terms of distributing that. But this ability to copy and share data or information at near zero cost, it has its downsides for certain applications as well. So if we think of things like Napster and the disruption that caused to the music industry, also illegal copies of content, the Pirate Bay and BitTorrent and all these areas. So there's downsides depending on the use and the domain of digital information and the ability to copy and share it. So it depends on the application. And from this, sometimes you don't want digital data to be duplicated. So if you think of tokens that represent value, so go back to our example of cryptocurrencies here, or you can even think of your bank account. So that those euros that you have in your bank account, that the bank holds that record for you. There's no physical printed money, or there's no gold standard behind that in most countries. So and then going back to that centralized authority on that. So it's a central bank or trusted banks that are highly regulated, that are trusted to maintain that they're not creating and basically copying those digital assets, creating new euros, for example. And with cryptocurrencies, it's that blockchain solution that can ensure that. There's also, if you think of digital representations of physical assets. So, for example, you can digitally represent land deeds. So there's only one piece of physical land. The representation of that, you really don't want that to be copied. There's probably one owner of that physical land deed. You don't want multiple owners to say, hey, I've a copy of those land deeds, and then disputes over ownership and so on. And currently, traditionally, there'd be a land registry, usually a government organization, again, a central authority that would manage those assets and make sure that that data is not copied, and it would have the one authentic record of that. Traceability applications as well. So if we imagine a lot of emphasis at the moment on traceability in food supplies and food supply chains and so on. So if you have your farm to fork beef traceability in place, and that's represented digitally by some digital identifiers for each steak or each piece of beef, for example, you really don't want those digital identifiers to be copied, because then you can't trace those individual unique physical assets. Supply chain management as well. So there's a huge amount of talk about supply chains, particularly we've all experienced that, I think, with the disruptions with COVID and Brexit also at the moment, and tracking digital assets through a supply chain is hugely useful to manage those supply chains properly and efficiently. But again, we don't want to be able to easily duplicate those digital tokens representing the real physical assets in that, because we want to represent those by a single item. Digital identity is another case here. So having a digital identity for a person, there's one of you don't want that duplicated. In fact, a lot of identity theft and so on is around how a digital identity might be duplicated in that key that represents you for various services and things you might access. And another one is ownership and authorship as well of digital items. So one of the sort of hot topics recently around blockchain is NFTs, or non-fungible tokens. And what these refer to is a digital token that represents an asset, and that could be a digital item itself. So if you think of a piece of digital artwork, the artwork itself can be easily copied, but you want to register the ownership of that asset, or the authorship, who actually created that. And when you are representing that through a digital token, there's only one author maybe, or one owner of an item. So you only want one digital token on that. And if that's, copied around at zero cost and shared, that kind of defeats that particular use case of having that token to represent that. And what blockchain and distributed ledger technologies do is they solve this problem, and they solve it without relying on a single trusted source of authority. So Bitcoin, for example, it doesn't have a central bank. There's no central authority that everyone trusts, and it's not the centralized view of the world where everyone needs to verify that do I own that Bitcoin? If I transferred it to someone else, is it gone? I don't own it anymore, and that other person now has ownership of that token, for example, that Bitcoin. So we don't need a centralized authority to maintain all that information. What we have instead with blockchain and a distributed ledger is a completely distributed view of that information. Now, the thing is here, although there's multiple parties in here, they don't even need to trust each other. So each of these participants, they don't necessarily need to trust each other, but they need to trust the technology. They need to trust the blockchain infrastructure itself. So the trust is transferred from between different entities, between different parties that are transacting or are sharing information, and the trust gets transferred to the actual underlying technology itself, and trusting that that technology works and is stable and does its job, which is the case for these blockchain implementations. So it takes away the single source of trust and provides untrusted entities to be able to share information and know that all that the information that they're sharing, it's all the same across all the entities, and they can trust that everyone sees the same source of information. So that's a sort of overview, I suppose, of blockchain, and an introduction, I suppose, where I was trying to give what the problem it's actually solving underneath. And this can be applied then to lots of different application areas. So we're now going to go on to talk about AI and just show some of the problems with deploying and adopting AI, particularly in enterprise scenarios. And then we'll revisit blockchain and talk about how those can solve some of those problems. So when we think of AI, here's some examples here of surveys over the last, quite recently, over the last couple of years on enterprise and people in industry on what are the key challenges in adopting AI, in deploying AI solutions in their industries, in their companies. And what we can see is near the top of all these different surveys and some of the key aspects, they're all related to data. So we see lack of data or data quality issues, problems with the labeling of data, augmenting, aggregating, identifying correct data sources, the quality of the data in terms of dirty data. So that means that the data isn't nicely represented, and there's lots of errors in it and so on, or the data is unavailable, or it's just very difficult to access. So a lot of these come down to the data, and data really drives AI. So this is sort of a key aspect that's fundamental to AI solutions, particularly in modern machine learning type applications of AI. And these modern machine learning algorithms, they require a lot of training data in many cases, particularly these new deep learning approaches that can do amazing feats that we've seen recently, particularly in sort of image analysis and many things that we actually take for granted now. If you do an image search online using Google or other search engines, you can just type in a keyword and you get relevant images. And this is AI powering that underneath to analyze what's in those images and classify those images under what's actually contained in those. And to do all this takes a huge amount of data. So some of the open data sets that are typically used in machine vision tasks, as an example, ImageNet, there's 14 million labeled images. Google have an open images data set, a publicly available one. There's 9, it's probably more than this now, there's 9 million and counting example image data for that. Audio applications, so if we think of the Alexas and the Siris and so on, companies probably have a lot more of this data in-house, but some of these open data sets that researchers can use, so audio set, there's 5,800 hours of labeled audio clips and that. So it's a huge amount of data. And what you see on the right here, this is just sort of a bit of work that we've done previously in CeADAR, looking at the amount of data that some of these algorithms need, and how, as you increase the amount of data, you improve your quality of your models. So going to the right here, as we go to the right, that's increasing amount of data, and we see the accuracy on the y-axis here. And as you increase the data, these 3 different machine learning algorithms, you can see the accuracy is increasing. And the blue line there is collaborative, or sorry, CNN deep learning approaches. So this is a real modern state-of-the-art machine learning approach. And as you can see, it starts off not so great with small amounts of data, but as you keep providing with more training data to improve it, the accuracy can way outperform, as the data keeps improving, can way outperform more traditional techniques, but it does need a lot of data. A second issue is data quality. So many types of AI models require properly annotated training data. So you can't just put in unlabeled data. You don't just throw the data into these models. The data has to be organized and structured in a certain way and annotated to tell the machine learning models actually how to interpret it and what the task is, what they need to learn of the data. Cleaning the data and correcting and formatting it, it's very manually intensive. And poor quality data leads to poor quality AI solutions. So as a couple examples here, I think the TAE example on the left. So this is a sort of an automated bot that Microsoft produced. This is a number of years old now, that was trained on a data set from scraped off the internet. They had to take it down fairly quickly because it started replying with hate speech and sort of racist language. Now, it's not a problem of the technology because they used data from the internet. The internet's full of that, that kind of stuff. So the technology worked perfectly. It was just the data it was trained on wasn't suitable for what they wanted here. So the poor quality data came out in the outputs of the chatbot. On the right hand side, this early example of automatic language translation and showing some of the bias that you can get in data. So the original English is he is a nurse, she is a doctor. You translate that to Hungarian, you take that Hungarian and you use the reverse in the system to translate it back, and you can see it switched the gender there. So biases in the training data set come out through these models as well. So there's a problem with the quality of the data, or an understanding really of what is in the data, and then that comes out in the solutions you produce. And a third aspect is accessibility of the data, and this is really where we're sort of going to explain later where blockchain can help with this. So data is often siloed across different departments or different databases, and this is even within a single organization, and also across multiple organizations. So again, the supply chain example, you've many different organizations working together in the supply chain, all with their own data, and sharing of that data, or the ability to access that data across all these different individual organizations and participants is very challenging, and is often closely guarded and protected. So data is valuable. There's whole industries. There's some of the most successful tech companies have their values in the data they have. They provide these tools and services for us to use for free. But it's the data that they're gathering through those that is the value that then they can produce value out of that, and services out of that. And the data can also be seen as a liability. So with GDPR, there's maybe a fear in sharing and opening up data sets because they might be breaking privacy laws inadvertently. So these types of data challenges with AI are really fundamental. And they're quite, they go against the adoption of AI and the deployment of AI, and there are challenges that need to be overcome. So bring back to blockchain here. So how does blockchain help with this? And how is it related to artificial intelligence? So as we've discussed, sort of the core problems that blockchain solves, the core issue that it solves, going to now just show how that can be used to support and solve some of these data problems that artificial intelligence has, and some of the bottlenecks there. So looking at blockchain as a shared and trusted data model for AI. So what blockchain provides through how it works and through what explained is predominantly trust. So organizations, as I've explained, they don't have to trust each other in order to trust the validity and integrity of the shared data. So they can share the data that they have between each other, and they can trust that that shared data is the integrity of that data, but they don't have to trust each other necessarily, and they don't have to trust a shared middleman that keeps that view of that data. So every organization can be certain that the data that they have is correct, and it's the same as everyone else's copy. So what this provides is a single sort of version of truth of the data. And this is hugely useful in AI applications where you need to trust that the data that the AI model is trained on is the data that everyone agrees is the correct data. Immutability is another aspect of blockchain. So this is where data, it cannot be subsequently modified once written to a blockchain. So it's a complete history of changes in that data. Now, you know, in certain applications, you can think this is a negative. So what happens if you make a mistake in the data? Is it there forever? But the way to think of this is it's not like that. It's data can be corrected and modified and updated continuously, but there's a record of all those changes that can be included on the ledger, and everyone can see and trust in all those changes and all those updates. So it's a much more comprehensive version of that data that can be shared. Also with data ownership and privacy. So organizations can control who's access to the data. So blockchain and distributed ledgers, they're not a free-for-all where everyone just shares their data, their private data is gone, and everyone else can see that. Not at all. It's gives the ability for individual participants to really control through very secure methods exactly who can see what. And there's also permissioned and private blockchains as well that only certain agreed participants can take part in. And these are used much more in sort of enterprise applications of blockchain as well. Security. So blockchain is very secure and difficult to hack. So, you know, the example of Bitcoin, which, you know, there's a huge incentive to be able to hack or corrupt Bitcoin networks. There's a huge financial reward. I'm sure many people have tried and are trying, but it's never been successfully hacked. So it's hugely strong, reliable infrastructure, reliable solution for doing this task. And finally, smart contracts. So you might have heard of smart contracts in relation to blockchain. So we've talked about static data, or data being stored on these shared ledgers, on these blockchain networks, the ability to share just the digital information as in sort of static data. But digital information can also represent certain functionalities. So this could be a certain process, a certain way of doing things, an algorithm, and these can be shared and executed on the ledger as well. And with this, much like people can rely that that data is that single representation, that single version of that data, this functionality, people can see how it works. They can see that what's going to be executed, what the process is, and they can all see what that is and verify that. And this can be used in managing data for AI applications, where you can use smart contracts to, for example, automatically validate data and the format of that data that's going onto a shared blockchain. So you can use this to kind of ensure that the data is consistent and that's verified what's going on to these shared data solutions. And just giving a quick example then of using blockchain in the context of these AI solutions. So CeADAR, along with Exertis, which is a supply chain management and services company, and Sona Lake, which is a software solutions development company. We're working on DTIF, so Disruptive Technology Innovation Fund funded project on applying blockchain solutions for supply chain. And it's particularly looking at the potential for applying AI in these supply chain related applications. So there's opportunities for improved predicting demand prediction. There's a lot of potential efficiency improvements. There's opportunities for automated decision making. So a lot of this is done manually in current supply chains. It's very inefficient, it's slow, it causes problems, the data isn't being shared efficiently. And automation of a lot of these manual processing tasks can be done through AI techniques. But blockchain or supply chains kind of currently look like this at the moment. They're very disconnected. There's lots of entities. Now, this is a small one. If you can imagine a few hundred maybe different entities in this, the data is siloed. There's very limited sharing of data, and there's no complete end-to-end view of really what's going on. Each participant sort of just shares data on a need-to-know basis with each other, and it's very diverse and incompatible data formats. Whereas a blockchain or distributed ledger view is where we have a shared data model. We don't require a sort of trusted third party to manage this all that everyone has to agree and interact with. It's the network, the blockchain network itself supplies that. And entities, they still own and control their own data, but they benefit from sharing this through AI and advanced analytics techniques that can be used over this data to provide value for everyone. So there's a few limitations, obviously, in using blockchain for AI applications. So it's not a database. There's a high computational overhead to provide all this trust and integrity of the data. So you can't sort of query it. You can't easily get the information out. You want the way modern databases are designed for very sort of rapid and efficient data access. You have to still trust the correctness of the data being written onto the blockchain. So, you know, the data is you're ensured it's the integrity of it is correct. It's not going to be modified or changed. But the data that's going on, blockchain can't provide the correctness of that. It's still up to what is produced and what is recorded. And a key one is also you need buy-in from participants. So this is a real challenge in many blockchain applications, that you need to have agreement from all the participants to belong to this, to sign up, to agree to be part of this different way of doing things, this blockchain network. And I'm going to just finish up now with just, I suppose, something for discussion. So if blockchain's so great, it solved these real fundamental problems with tokens, with digital information that we can find all over the place, why isn't it used everywhere? There's the proponents of blockchain, early proponents were talking about it in similar case to the early internet. Early internet's fundamentally changed our lives. It's everywhere. People were talking about blockchain in the same way, solving this fundamental challenge, working with digital information. So, why isn't everything on blockchain now? I think there's a few reasons for that. So maybe that's something that we can discuss. So thank you very much.
That's great, Oisín. Thank you. So, sorry, while I try to get my camera turning on. We're happy to take questions now if people have them. So you can use the questions tab on the right-hand side as you see them. So I have a couple to start with. Maybe it seems obvious from what you're talking about, Oisín, that the likes of financial services, technologies, and stuff are big users. Are there any other, I suppose, non-obvious sectors that use blockchain?
So, I mean, I think people have been looking at applying blockchain across all different areas, like a lot of different areas. Some of those maybe are questionable in terms of the value of it. I mean, I think a few years ago anyway, slapping the title blockchain on a company name or on something they're doing is, was guaranteed to increase your share price. I think we're sort of beyond that now, and it's going down to the real applications of that. So I think any sort of industries or areas where there's information needs to be shared between different parties that don't necessarily have to trust each other, but then there's a benefit in having that shared data is something. So we're seeing that a lot in the likes of the project that we're working on in supply chain. So there's a lot of supply chain uses of this in traceability. So sort of track and trace and so on. There's a lot of looking at using this in terms of sort of government information. So I mentioned the use case of digital identity. So governments have been looking at using blockchain-based identity for citizens in accessing sort of government services and so on. So there's a lot of these areas. One of the things I think, though, is blockchain has been so sort of associated with Bitcoin and cryptocurrencies that it's kind of difficult to sometimes get away from that view of blockchain, and it's, you know, the other uses other than these financial kind of use cases, and also around Bitcoin and so on.
And do you think that association has given them a bad name, for want of a better word? I mean, is there a negative connotation of that association, do you think?
Yeah, I definitely, I think there is that is part of it there, and particularly with Bitcoin, you know, that's always in the news because, you know, there's a lot of speculation around Bitcoin. And in fact, I think the original sort of idea and the founders behind Bitcoin was that it was going to be this really usable currency that's not controlled by you know, any one entity, and it's sort of real you know, open and so on. And what's happened with Bitcoin, really, it's just in a it's just used as something that people speculate and invest on. So in terms of an actual currency for buying and selling stuff on a day-to-day basis, it's failed from that. So some of that sort of negative press of that and the kind of controversy around cryptocurrencies, and, you know, there's been a lot of fraud. It's used for, you know, it's associated with sort of illegal activities as well. I think that is going against sort of the trust in this technology in other areas.
Okay, so maybe just look at one of the questions coming in. Are there mature off-the-shelf software solutions for companies to use who want to explore blockchain?
Yeah, so there are, you know, a lot of the big players in technology are developing their own and have developed their own blockchain platforms for different circumstances. So many of these are designed at more enterprise applications. So they emphasize things like it's a permissioned blockchain, where it's got a strong security of who can see the data, as some of those aspects I was mentioning. They're designed for sort of enterprise deployments and so on. So some of these will be like the Hyperledger Foundation, Hyperledger Fabric, Oracle, Microsoft. A lot of these have their own blockchain as a service kind of scenarios. So, you know, there are relatively mature technologies that companies can take and start using right now. However, at the same time, it's still relatively early days in where blockchain's going. So there's issues with sort of incompatibility across different blockchain implementations, and certain challenges in that still. So it's a bit of both. But one of the aspects is the expertise needed to develop a blockchain solution as well. So in terms of an off-the-shelf solution, you really need a deep understanding in how it's been applied and the applications it's been applied to, and then you need sort of expertise in terms of your software development teams in understanding blockchain, how it works, and so on to get a solution. So it's not something that can be just taken and applied straight away, I think.
So is what I hear you saying is that nearly there's a minimum level of capability and infrastructure in a company that a company would need to implement successfully some kind of blockchain solution.
Yeah, definitely, that's true, and that's from a technical perspective as well as sort of the use case perspective. So understanding the pros and cons in its application to a certain you know, a certain purpose and a certain scenario. And actually, that's something in CeADAR that we've done a number of projects with industry partners actually in, you know, assessing the suitability of a blockchain solution for a particular business problem that they have, and then helping them bring that up to a proof of concept level as well.
Okay, so sorry, I'm just going to read this question. It says, interesting the visual representation of the supply chain example compared to the previous decentralized blockchain network. Almost looks like the opposite representation, i.e. the supply chain solution looks more centralized than the current decentralized description.
Yeah, well, I mean, yeah, so I suppose centralized here is, by centralized, we usually mean that all the information is managed by sort of a single point, single central authority. Whereas in a blockchain solution, in supply chain or whatever else, the information is distributed. So there's no single entity on that blockchain network that is the sort of gatekeeper of the information. So all those participants are equal participants and sharing the information, but it doesn't have to go through one single source.
Okay. Is there any measure in blockchain to make sure that the shared data on the ledger is not plagiarized or copied by another participant, especially in the case where a similar type of data has been pulled together by different competitive organizations?
Yeah, so I mean, I suppose that's one of the things about information on a blockchain. If that's accessible to someone, there's nothing to stop them taking that information and making, and copying that information. It's not, blockchain doesn't solve the kind of data access, the security problem of people making their own data secure. So, the information that's on a blockchain, for those entities that are allowed view and get access to that information, they'll see that information. They can make their own local copies of that. But in the context of sharing that information, what the blockchain solution and distributed ledger solutions do is make sure that there isn't duplicate versions of a single digital item shared on that blockchain, for example.
Okay, and I suppose just to comment, the next one, blockchain has been used for racehorse ownership, so that's an interesting one. Are there additional challenges ingesting data from the blockchain to AI ML models as opposed to traditional annotated data feeds?
Yeah, so I think that was one of the points that I think distributed ledger technology and blockchain platforms, they're not a database. So modern databases have been designed for easy, very quick access to data, handling large volumes of data and querying that very efficiently. What a blockchain solution is, that's not the key design in a distributed ledger technology. The key design is to ensure that consistency of all the copies of that data that's distributed to all the participants. So accessing large volumes of data from current blockchain platforms is challenging. But what's often done is a token or representation of off-chain data is stored on-chain on the blockchain. So people can verify that the data that they have stored locally, and maybe a more efficient database solution for that machine learning and AI applications can access, they can verify whether that digital token that represents that data is correct, and they can ensure that data that they're using is valid and is correct, is the single source of data.
Great. We have 3 minutes left according to the timer on this, so there's a couple of other questions. So maybe just some short answers, if that's okay, Oisín. What's the skill set needed to create blockchain apps, coding SQL, understanding of network protocols, EDA, ?
Yeah, so that there's particular skills in understanding how to deploy blockchain platforms, things like consensus algorithms, how to set them up, how to configure them, and so on. The sort of low-level network stuff is usually handled by the platforms themselves. So software developers can, I think, upskill fairly easily, but they need to focus on particular blockchain applications and learnings around that.
Right. Okay. And how do you see this is the last one I'll ask out. How do you see the combination of blockchain with federated learning?
Yeah, so that's an interesting area. Actually, I didn't talk about that. So in terms of privacy preserving machine learning, which we're doing a project at CeADAR on at the moment as one of these collaborative research projects, and it's looking at some of those aspects. So blockchain could be used to support the federated machine learning, so running those machine learning models at different locations and using the outputs of those models, combining those in a more central location, preserving the security and privacy of the data at those individual areas. And yeah, blockchain is something that could be used in that context for sure. That's something that we're looking at. Yeah.
I will ask this very last one, Ed, because it should be a yes/no answer. Bitcoin, hodler, or altcoin? I don't know.
Wouldn't touch it with a barge pole. It can go up and down.
All right.
If I had loads of it, though, I'd be saying something different, but unfortunately, I don't.
All right, fair enough. Okay, listen, thank you very much, Oisín, for your time and a really interesting conversation this morning. And there are 1 or 2 questions still coming in. So what we'll do is we will ask maybe Oisín to write a small written reply to them, and we'll send them out with the link to the video recording of this. So again, I'd like to thank everybody for their attendance this morning. This is a webinar as part of our series. We will have one more in the series in early November on the future of work. So we'll have details of that on our website. And as I say, the event today is recorded and we will be sending out details, but you can go direct to the technologygateways.ie website or into our YouTube page, and you'll find the link to the video recording. So again, thank you everybody for today, and see you again at the next one, I hope. Thank you. Bye-bye.